to get started in ESPRIT Edge, I just wanted to look through kind of what we're dealing with in this this scenario, in this program. So you can see we have a Doosan DVF 5000 machine. It's a 5-axis trunnion machine. And we've got our stock set up in here. We can rotate around and just kind of take a look at things. One thing I wanted to point out, as Mark mentioned, there's an addition to ESPRIT Edge where we can get the machine axes. And I can actually use this here to see what that's going to look like as the angle changes just within my machine view. I don't have to be in simulation or anything like that. I just click on that machine button, and then I can rotate these axes around just to make sure everything looks accurate as far as the machine I'm using. So I'll go ahead and reset all of those to 0. And now I'm going to go take a look at the tools that we have prepared in this file, still in this machine view. If I go to the tool assemblies on the project manager window, then I can see I've got 6 tools created here. And as I click down on each one, it shows me the holder and the tool. So you can see if you drop down the little caret, you have a tool holder and a tool. Each thing you click on, it'll highlight, so you can really go through and check your tools, make sure everything looks good. And so it's very easy within ESPRIT Edge to see where you're at. If you're picking up a program from someone else, then you can easily get caught up to speed because the user interface is so friendly to be able to find out what you're really working with there. Now, if we're done checking on our tools and machine, let's go take a look at the part itself. So I'm going to switch over here to the part view. And there's a lot going on when we first take a look here. Lots of red, which represents the tool path that's being drawn. So what I'm going to do is I'm just going to turn off that tool path. I come up to my little masks. I'll turn off tool path, and that will just hide it. So then only when I select one specific operation, then it'll highlight that toolpath, but otherwise it'll keep all of the toolpath hidden for us. And so we can take a look at this part. Lots of surfacing, lots of 3D 5-axis surfacing on this part. And because it's a fun 5-axis part, I figure we can simulate through and just do something small just to get a taste of what simulation looks like on a 5-axis part in ESPRIT Edge. So with this selected, I'm going to head over to simulation, and I'm just going to single step. And that way it'll just get its thinking. It'll go through all the other operations up to that point and calculate the stock so that we can see that now. And then I'm just going to, let's see, let's turn it there. That's a little fast for us. Let's slow down a little and enjoy it. Here we go. So you can see it turning. You can watch the machine, all those axes working together. So this is giving you accurate simulation of what you should see on your machine. So any collisions, any odd angle changes should show up in here and make it easy for you to correct before even posting out NC code. You'll be able to go through and see all of that. So it's a pretty cool little operation. We slow it down all the way. You can see just how detailed those axis rotations are, all programmed within ESPRIT using composite cycles to wrap all the way around there with 5 axes and avoid all collisions. So there's a little taste of what it's looking like. One thing that I would want to go over next is the machining cloud side. So ESPRIT is integrated with machining cloud. If I go to my tooling tab on the ribbon here, all the way down at the end, I have this Machining Cloud connection add-in, which you can get from the Machining Cloud website, and I'll show that in a moment. But you can import tools easily into ESPRIT using this connection. So let's go through the process. Let's say I wanted to change this chamfer tool that we have to do the engraving on the front of this base. If I wanted to change that tool and I want to find something specific, then I'm going to want to go over to Machining Cloud. And let's go right here. So within Machining Cloud, we'll be able to do a search for anything we want to find here. So you can put in any keywords about a tool or a holder, and it will return results filtered using that search. You can browse through catalogs, which is going to be, you could go through the Kennametal catalog. You can go through just about anything, Heimer here, Haas, Ingersoll. You've got all these different tool libraries, and all of them are pretty extensive that Machining Cloud has created for you to find the correct tool, the exact model that you are using at your machine. So what I'm going to do is I'm going to start by looking for a tool holder. And the tool holder that is found in the machine we're using is an AK182 Cat 40. You can search the entire model number, or you can search a part of it. If I were to search Cat 40, then it's going to bring up a few different options, and these are only things that relate to Cat 40. If I go into adapters here, then we have all of these Cat 40 adapters that we'll be able to use. But maybe we need something a little more specific than that, right? So what I might do is I'll put in the AK182 Cat 40 just to narrow down the results. And that will give us exactly that adapter that we want. I can click in on this. You can see you can add these parts to your cart and buy from MSC as well. I guess they're integrated with that. It makes it a very clean process for buying and using tools that you need. You can check out all of the parameters, the dimensions of it. And the other thing, what we're really interested in, is creating a tool assembly. So up here, this button, if I click on that, it'll take a second to load, and it'll bring us to a page where we can add adaptive items between our Cat 40 holder and the machine, or we can have parts that adapt towards the tool. And so we're just going to use this Cat 40, and we're going to look for a tool item. And what we really want is a chamfer tool. And we can see up here, this is the library that it's looking in. So it's saying the adapter or the holder that we selected fits with these tools. So then what we can do is we can come up to our quick search. We can put in chamfer. And when I hit enter, then it's filtering down to only the tools within that library that are chamfer tools. So then you can see it's got solid carbide tools, and it'll show the materials, and that's part of what goes into the speeds and feeds calculations that Mark was mentioning as well. So I'm just going to come in here. We want a 10 millimeter chamfer tool. And so I'm going to look down here. This is in inch, but 0.3937, that's our 10 millimeter. So I'll select that one. And then the button we have here is add to tool assembly. So I'll click there, and this will take us back to the page. We have our tool holder, we have our tool. So now what we can do is we can export this and be able to use it within ESPRIT. So you can do that by clicking the export button up here. And it'll have ESPRIT Edge as a partner to export to. And then what it's doing is Up here is where it is exporting that tool into a zip file, and it will be available to download and bring back into ESPRIT. So now we'll head back over to ESPRIT, where we're going to use that machining cloud connection. And I'm going to import tool assemblies. I'll open a job and use this chamfer.zip. And so now we see that assembly put together. And we can go to do import validations. This will show you if there are any errors in missing data that would be required within ESPRIT, and you'd be able to rectify that or add that information. But I'm just going to send this file to ESPRIT. Once we get that green check, we should be good, and we can go to our tool assemblies, and we should see, yeah, this one open here. We have our AK182 Cat 40, and we have our chamfer tool listed in there. So now with that, we want to test this out. I want to see if this tool is really going to work the way I want it to. And so I'm going to go to our engraving operation for the logos. And I'm going to change from the old chamfer tool to the new one. And as I change that, it's going to take just a second while it calculates over here in the program window. It's verifying the links between operations as well as the toolpath itself, making sure there will be no collisions based on that change we made. And as soon as we get that check, then we are ready to go. So I'm going to select that operation, come into simulation, and we'll queue it up. So now that we're in simulation, we can come down, and I might remove part of this view because it's nice to see all of the machine, but the walls of the machine, the door, aren't really going to do us much for simulation. We can probably get away with just using this trunnion table and the head. So with that, I'll go ahead and bring it into a view so we can watch it cut. And then as I press play, I can see it's cutting. We're not getting any collisions here, no gouging, but it's not really looking pretty. And so it looks like the tooltip might not be the style that I thought it was when I imported it. It looked like a sharp tool, but let's go into this chamfer tool. And we can see the shape is to have a flat bottom. And so the nice thing here is that the tools, once they've been imported from Machining Cloud, they are really just an ESPRIT tool. It's already done all the work to transition all the information into the fields for ESPRIT, and now it's just an ESPRIT tool. So we can change it however we want. I can give it the shape that I want, and you can edit any of these parameters as needed. So it can work really well as a base tool if you need to, you know you're going to need to modify things. But a lot of the time, you'll be able to find that perfect tool that's exactly like the one that you want. So I'll go ahead and change that. I'll watch again. These links are calculating just to make sure everything is good. Let's see. Let's go. So let's go ahead. Let's just try and start the simulation here. And what I'm going to do is hit next. And so this is what it's going to show you just as an example here, because we weren't waiting for those links to finish. And so what it does is it brings us the initial stock, and it tells us that it's in the starting state. It can't give us the stock simulation because those links had not calculated yet. And so it backs us back out of simulation because it says you need to have those links ready. So now that they are blue and check, now we can step into it. And now we'll see that as it pops up, it's going to have our intermediate stock here. So we've got all of that surfacing finished on Batman. We're just going to do the engraving here. And I'll go ahead and play simulation. We can see this time the text is much more clean, much more slim. So we can see that pointed tool is doing exactly what we wanted it to do. And that's how you'll be able to kind of utilize those machining cloud tools. You'll be able to create them based on what you have in the shop or what you're planning on buying. You can import them into ESPRIT. You can edit them in ESPRIT as needed so that you're able to get the results you need. And all of that is very powerful when trying to optimize your time and reduce costs within the shop. And with that, we're going to step from ESPRIT and Machining Cloud. We're going to go ahead and look into ESPRIT and NC Simul. So Danish, why don't you take it away?
Thanks, Ben. That was a pretty neat overview of Edge and Machining Cloud. So I'm going to start to share my screen here, guys. All right, so basically I'm just picking up from where Ben left off. And so before we dive into the technicalities of it, let me just introduce the software NC Simul, if some of you haven't heard or haven't used it before or haven't seen that in action. So NC Simul basically is a simulation, verification, and an optimization software. And what we are doing today is the Batman project that Ben worked on. So we're going to be looking to export that directly from ESPRIT. So we're going to see the process of transfer. Is it if it's easy enough um, or if it's like tough for us to set up our job taking a project from ESPRIT to NC Simul. So for the easy transfer of the project, we have this interface in ESPRIT for the NC Simul. And this is the kind of the tab for it. So let me go ahead and open that. So the neat thing about this is it's kind of very, very compatible with the ESPRIT in terms that whatever data selections that you have made in Edge already, so it's going to automatically pick those up. So in my case, the machine that we are working on is DVF 5000. So it kind of already picked it up. Okay, this is the machine that we are working on in the Edge side, and then do we have that available on the NC Simul side, which we call it a digital twin. So of course we have the machine available, but if I want to put it on any machine, so we do have the capability. And as Mark pointed out earlier, so this software is capable of verifying and simulating not only the 5-axis machines, but also any of your multi-channel lathe configuration machines you have, and also the complex multitasking machines. So it's very, very capable in terms of verification and analysis. So right now we're using the same Batman project, and what it needs as of the information is we need to tell, okay, which geometries do we need to export, so it automatically picks it up, okay, which is our part geometry, which is our stock geometry. And we don't have a fixture for that in ESPRIT, as you may have seen that, so we're not going to export any fixture, right? So apart from that, so it detects automatically basically the whatever tools are associated with it, so we don't have to manually select those. And then there is an option if we want to generate the NC program directly, or in terms like internally from ESPRIT Edge, or if not, we can add our NC program directly from here as well. So in my case, this is my NC program, so I have just added that. And initialization is basically just what datum that we are using. So if we are using G54, G55, I'm talking in terms of FANUC, so it just picks it up automatically. And the beauty of NC-Simul is it's CAM agnostic. So even if you are using multiple CAM systems for various of your other needs as well, so it is very, very compatible with all the leading CAM systems out in the market. So not only it's compatible with ESPRIT Edge, but if you're using any other CAM system, so it will give you the tools necessary to do the transfer as well. All right, so all after making the selection here, all I have to do is click on the export button. And once we do that, we will go into NC-Simul. And this is kind of what the project is going to look like when we transfer our project directly from Edge. Right, so in here, I'm gonna give you first an overview of the user interface, right? So on the left-hand side, we have the resources for our job setup. So which basically which geometry is going to be our stock geometry, which is going to be our part geometry, where our G54 is located. And again, I didn't have to manually type in anything. I didn't have to manually set up my job. So it took up the same information that I have to create a virtual setup. Now, you may have, some of you may have the question that we have run the simulation in ESPRIT Edge or in any CAM system that once we run the simulation, why do we need a verification software, right? So the biggest difference is the simulation you run in your CAM system is like verifying the generic XYZ moves, the IJK vectors. And the difference in the NC-Simul is it's actually verifying the G code you're going to put on your program. So you can verify it for any types of crashes, any types of um, format errors in the code, or any alarms you may get. So it's going to kind of bridge the gap between your CAM system and the machine. So the first time you run the code on the machine, you know how exactly the first thing that we want to make sure is we don't have any crashes, right? So because our machine is an expensive piece of equipment which we want to protect. And also, which we're gonna discuss a little later as well about the analysis features available in the NC-Simul is if we run that part on the machine, okay, it's not crashing, that we are not alarming out on the if that part that we are trying to make is within the dimensional tolerance that we want, right? So the other thing that we want to avoid is we want to avoid our machining time directly spent, right? So the goal really is to the first time we go out on the machine, we are very, very confident that we're gonna make the right part within the right specification and we are not wasting the machining time, right? So because it's costly uh, um, as well. All right, so discussing about the data transfer. So all of our tools have been automatically transferred over. Uh, uh, as far as the tools, yes, the tools do come over automatically, but if you want to import those directly from Machining Cloud, that is supported as well. And if for the same project that you want to share the tools database with another users, you can do that as well. So all the tools defined with the shanks, the flutes, so all of those are coming in automatically. So I didn't have to manually make any changes to those, right? And what NC-Simul likes to do is it likes to divide the NC program into different tool sequences for ease of simulation and for ease of identification purposes as well if we have any issues with the program, right? So I'm gonna enable the stock. And some of the tabs that we have at the bottom is the if we have any errors. So this is one of the errors that we got is again, very good point that we can bring it up with this one. So this one is telling us is that the rotary axis need to be at 0 before the TCP can be enabled, right? So this is basically a machine setting, right? So NC-SIML can really take, so we're not going to provide you a generic machine model. It's going to be the exact digital twin of your machine with the same settings that you have, right? So the exact same settings that you have on your control, that's gonna be replicated on the NC-SIML side. So whatever results you get on the NC-SIML side, even some of the alarms, so you can expect the same thing on your machine as well. So at the end of the day, when you're taking your code, you're really confident, okay, this is how it's going to behave, right? So it's a machine setting that we can and where exactly it is going, so we can turn that parameter on and off on the machine, right? So if the rotary axis need to be zeroed out for TCP to be active or not, right? And some of the other things that we can really use is if I click on any move in the toolpath, and I want to check, okay, what feeds and speeds am I playing with? What tool is currently in action, right? So, and what is the position of my tilt and rotary? So I can basically go down the whole program and check for any specific line. This gives me the information about the whole of the NC program, right? More time synthesis based. Okay, I know this is going to be my total time, but how much time each tool sequence is taking, and then how much of that is the actual cutting time, how much of that is the actual rapid time. So I can make informed decisions even if I need to go back to my CAM system to make some adjustments. So I know, okay, this is what I need to target exactly, this because this is the result I'm getting in the NC-SIML side. And also with NC-SIML, it cannot only simulate your NC program, but any macros, subroutines, and probing routines you have, it can simulate that as well. So that's a great advantage you have with the NC-SIML. And on the right-hand side, we have our NC program where we can basically control the simulation, right? So the very first thing, of course, we're going to do is we're going to start our simulation. So this is the simulation option. There are different modes available in simulation. So the most common one is the continuous simulation, but we can use others as required. If we want to run it to up to a breakpoint, we can insert a breakpoint using this particular option, or particular n blocks, or as a specific tool selection, and a few of the other ones, right? Okay, so I will start the simulation at an average speed, so I'm not gonna go crazy just for the start. So you can see it is actually reading the G code and manipulating the machine or predicting the machine behavior as it moves. So that's what we are trying to achieve is, and also one of the things that from my experience that I have found is sometimes because if you run the simulation in your CAM system, it cannot predict the collision between different tool orientations, right? So if you have what do you say, an operation or a tool path happening at one orientation, right? How far is the tool at? So if you may have seen that when the tool moved from one orientation plane to another, how far is the tool at when the plane changed? Is if when the machine changed its orientation, was the tool colliding or not? So some of those things specifically you would definitely need the verification side for. Now, this is the verification checking for any types of errors, right? But there's also a really cool feature in NC-SIML is the intermediate stocks, right? So I have reset the simulation. So what we can do with the intermediate stocks is it remembers the cut stock up to the point of selection in the NC program, right? So if I go ahead and activate the intermediate stock, and if I rerun the simulation, now what's going to happen is it's going to, with these green, it's going to remember how up to the point the stock has been cut. So if I need to take measurements, okay, I have ran like two tool sequences. Okay, are we cutting? Are we in the right size at this point? So at that particular point, you can stop your simulation and take measurements on the cut stock up to that point, right? So, and also one of the other things that I want to press or point to is the amazing speed of simulation in NC Simul. So right now we are at an average speed. So if I go crazy with the simulation speed, right, this might take in if I'm talking about some of the other verification softwares out in the market, I won't name many. So this might take around like 10 to 12 minutes for the complete verification to see to check for all the collisions. And as Mark mentioned, not only we can check for the collisions, but any near misses or dangerous moves on the machine as well. If any of the machine components are getting really close to each other, right? Not necessarily a crash. So some of those things we can detect as well. And in basically in a minute or so, we should be able to just verify this whole NC program with the crazy 5-axis contour surfacing to make sure if we are crashing the machine or not. And then what we will do is we will also run the analysis. So these are some of the analysis features available. So what we can do is we can set the tolerance limit. So while it is kind of going, I can talk about this feature. So once we are running the analysis feature, we can set up our tolerance. Okay, we want to be within 3 thou or 4 thou of an inch. And if the tool is gouging the part geometry by more than that, then we want the software to notify us. And the cool thing is it will let us know exactly how much the tool is digging into the part geometry, right? So based on that, I can make informed decisions. Okay, which tool sequence do I need to target in my CAM system if there needs to be a change in the toolpath strategy? And also, I can check how much of the material has been left over with the comparison stock. So kind of the full spectrum from top to bottom. Okay, now this is the plus 3 thou of an inch to negative 3 thou of an inch. This is kind of the tolerance I want to stay in. And if it's going anything up and down between that, then I want to be notified, right? So rather than having to find these things directly on the machine, spending hours and hours of your machine time just to make sure that you are within that dimensional tolerance, NC Simul can help you predict that the very first time without even switching on your machine, right? And the cool thing is, as I said, it's going to be an exact replica. And how do we make sure it is an exact replica? Because we will be getting of course, the machine data and all your machine files in terms of your settings, how the controller is set up. So once you have the exact sim ready digital twin, and so you're going to be very confident that with that behavior. So we are almost there at the 99%. I'm just going to give it a few more seconds before it finishes. And then what we can also see is as I'm going up and down in the NC program, I can see how much of the stock has been cut at that particular point in time, right? Because of these green icons, it's telling us that it has saved the intermediate stock. Okay. All right, so we are almost there. I'm just going to give it. All right, so it has finished now. So let's see. So this is going to be the cut stock, how it's going to look like. Now it visually looks good, right? It looks good. Okay, my cut stock part's gonna come up like this. Now, but if I am dealing with like very accurate parts, right? I want to see if exactly if, I am within that dimensional tolerance or not. Then we can use the analysis tools that we have, like the gouged material analysis. So it's again, it's pretty fast compared to some of the other softwares out in the market. So I would recommend some of you guys stay with me for because it's going to take about a minute or so, and it will calculate the points of defect, which means is like if I am out of that particular tolerance range. So this is the tolerance range, right? So starting with the negative 0.3 millimeters. So for me, I have set it to the metric. If you are working in inches, so you can type the units in inches as well. So it depends on you basically how you want to check it out, right? So this is the result at the end that we have. So it tells us exactly at what point we are gouging, right? And by how much exactly. So it's very, very accurate in terms of predicting the gouge behavior. And not only that, so if I kind of go down, some of these logos are kind of being gouged, right? So if I zoom in here, so you can probably see all those reds. So these are being gouged, and by exactly how much are we gouging, right? So it's very, very accurate in terms of visibility as well, that we can really zoom in and see. And if we are talking about numbers, then this is gonna let us know. Now, if we want to completely see visually as well, that okay, how does the actual cut stock look like in comparison to my programmed part? So now we can do a comparison. So now if you can see, it's running it at a crazy speed, and within less than a minute, we should be able to see the result in front of our screen. So I'm just going to give it a few more seconds before it finishes, and then we can see the whole comparison. Okay, so should be, there we go. So now it's kind of covering the whole bandwidth of ranging from plus minus 0.25 millimeters, right? And now, if I really zoom in, the really cool thing about is of course some of the materials that have been left over have been undercut, so those are highlighted in blue, and the green is basically telling us that we are within the tolerance limit. And the minor, the reds that you can see are very, very slight gouges that we may be having, right? At slightly at the contour, so these reds. So let me go ahead and click on some of the points just for the dimensional analysis, that, okay, at this point, how much of material are we leaving? So if I click on that, it's going to exactly tell me that we are leaving about 0.6 millimeters of material near the eyes of the Batman, right? So, and also, let's say if I click on this point, so it's going to tell me that. And if I click any point in the green zone, so we are within that tolerance limit that we have set. So that's how it has color coded. And again, it's very useful in terms for running the accurate parts as well. And same thing goes for the logos as well, that it's kind of highlighting that in green because we are overcutting into our logos by a little bit, and by exactly how much the analysis feature is gonna let us know based on the values, right? And now let's also talk about some of the measurement features so have come out of the simulation. Just gonna give it a few minutes for it to rethink. Okay. There's also measurements feature available. So not only in terms that you have to measure point to point. There are some standard measurement features available if you want to measure your cut stock. So if, let's say, if I want to check the thickness of Batman's ear, so I'm going to say, okay, I'm going to click on that particular point and I will wait for it to update. So without even me having to run anything on the machine, I can run complete analysis within the NC Simul, and that goes basically for your 5-axis, for your mill turns, for your multi-channel lathes, and your multitasking machines as well. So it's very, very accurate in terms of predicting the machine behavior. All right, so now what we can do is, okay, we have a good enough program we can run on the machine, and then we do have we know, okay, this is within the tolerance value that we are attempting to be in. But also, how can we take it up one step further? So there are some optimization features available. I'm not going to go in too much of detail in the interest of times. I'm just going to go over it. So the optimization, what it does is, let me share a quick screenshot. So basically, I ran the cut analysis for one of the tool sequences. So what it does, it gives us a time-based synthesis for that particular tool path. Okay, it told me initially this tool's gonna take up this amount of time, but how much of that is within material or how much of that is in out of material? So I can see that for a 52 or 53-minute tool path, my tool is staying close to quarter of 12 minutes out of material, right? So that means my tool is not engaging with the material for almost 12 minutes, right? So what can I do to improve the efficiency of my machine and reduce the cycle time? There are tools available in NC Simul where I can convert this timeout into a move or rapid move, because of course the tool is not being in contact with the part geometry. So NC Simul can find those specific lines where the tool is not interacting with the stock part, right? And then it can once it verifies identifies those lines, it can turn those into high feed moves or into rapid moves, whatever you're trying to achieve. And also there is feed rate optimization available if you want to have the constant chip load, if you want to have you want to have the what do you call, the chip flow as well. So there are different tools available which can really elevate the game in terms that you're trying to improve the efficiency of the machine, reduce the cycle time, and all in all get a good ROI on the product, that you're not in tons of machining time directly on the machine. And after everything is done, you have done all the analysis and you have optimized the tools, you would want to give something to the operator, well, right? So that will be, you can create a document summary of, so NC Simul's gonna do most of the work automatically for you. So it's just thinking right now. So hopefully I can do that before we run out of time. Okay. So I'm just gonna give you a quick preview of how it's gonna look like. So it's gonna tell us basic information to advanced level information about how much time each tool sequence has taken, and how the job is being set up. So it gets easy for the operator, not only for the programmer as well, that he knows, okay, how the machine is going to behave, but also for the operator who's going to load it, and how the tools are being set up. Okay. So here we go. So starting off with the project information, what all features were used, right? This is going to be the block where our G54 is located, right? So the information about different tool sequences. So I didn't create do a very good job of taking a screenshot, so it's taking a little bit off center, but yeah, this is what you can do manually as well, is you can take the screenshots according to your own needs, how you want to set it up, right? So and then you can also kind of manipulate how much information do you want to include in your summary, right?
So what is Machine Cloud? It's a tool database and includes tool assembly, so you can build your tools inside their platform, their application online. Then you can export those data files into your CAM program. It's not just a spree connection. There's other CAM platforms that you can connect with. Most users like to use is the feed and speeds, getting that with type of material that you're cutting and things like that. So why people do it is to hopefully decrease your setup time and also increase your tool life. So it's another huge benefit can be how you're buying your tools. They have a close relationship with MSC and able to purchase those tools. There are a few customers getting access to the latest release, which is Swiss. So a lot of people are anticipating this Swiss program in ESPRIT 2K today, being available in Edge. These are just dates that have been released both in July and here in September. So those being probing C-axis centerfind, 5-axis circle segment finishing, move machine axes, 5-axis remachining, operation suppress and unsuppress, and also supporting non-bisecting behavior and lathe contouring. Great update here, released this summer, was 3D whiteboard. So those that are on maintenance have access to this tool. If you aren't familiar already with the Nexus, you can share your design changes, queries directly with customers on your extended team with no CAD software required. Productivity using intuitive tools to collaborate with multiple stakeholders in a browser to review and agree to any changes. And then also we believe it'll lead to reduced costs or remove the need for complicated email threads and avoid mistakes. NC update last year and now this year. So read a few of those: decoding, new decoding mode, editing during calculations. One thing you'll find with NC is it can calculate really, really quickly with its special engine it has over other competitive verification software. And so simulation, limiting the work area of a turning tool. So you can do mill turn inside of NC the kinematics shared between Edge and NC. A lot of people like this ability because you can actually go into Spree and change things in Machine Tool Builder, and then naturally that would replicate inside of NC as well. And then you have a new risk of collision alarm, the addition of adding a number block. So if you want to add comments inside your code, you can do that inside of NC. So that takes care of these updates. If you want more extensive updates, we'd be happy to share this in more detail. Something that PMT has released, and it's been very popular, has been basically a self-guided training method on the site. So if you're wanting to get access to this, it is available on an annual subscription. We have 4 options you can choose from. Platinum training includes all 3 of them: turn and turn mill, milling, and Swiss. And then you also include training with those. So we'll spend time with you virtually at your own pace, doing more of a custom method. The videos that are prepared for you are already recorded. The files are included, and you would have access to these training videos. So these are available for ESPRIT Edge, specifically for return and milling, and then Swiss is available for 2K, since it's on the release of ESPRIT 2K.